Hello everyone, welcome back. So for today we are going to be doing cosine rule, and we are also going to be proving cosine rule. Now in one of our previous tutorials we did trigonometric ratios, whereby we talked about cosine, tangent and sine. And if I remember vividly, I remember saying that those trigonometric ratios are used for right angle triangle only. Now, cosine rule and sine rule, but we're going to be doing cosine rule for this tutorial. So maybe subsequently we can do sine rule. So cosine rule is used for a triangle that is not a right angle triangle. So you use cosine rule to find the sides and angle of a triangle that is not a right angle triangle. So when you want to find the side or the angle of a triangle that is not a right angle triangle, you are going to be making use of cosine rule or sine rule, which means that when you have an acute angle triangle or an obtuse angle triangle, which has one of the sides to be unknown or one of the angles to be unknown, you can make use of cosine rule or you can make use of sine rule. But I'm going to be starting with cosine rule for today's tutorial. Now, cosine rule simply states that a squared is equal to b squared plus c squared minus 2bc cos a. Now, these sides can also be interchanged. So if you don't want to write it this way, you can also say that b squared is equal to a squared plus c squared minus 2ac cos b. Or you can also say that c squared is equal to a squared plus b squared minus 2ab cos c. So this is what the cosine rule states. And the one you use depends on the side. Even the alphabet here can be changed depending on the alphabet that you were given as the side for the triangle that you were given. Okay, now that I've stated the cosine rules, the next thing I'm going to be doing is to prove the cosine rule to avoid confusion. And even when I give you the method to prove this cosine rule, maybe subsequently, if you forget the rule, you can derive the formula yourself, and it's even better. But if you can't, you can just know them this way. Now I'm going to be starting with an acute angle triangle. Now, an acute angle triangle is a triangle that has all of its interior angles to be acute angles. And acute angles are angles that are less than 90 degrees. Now, let's assume that this here is an acute angle triangle with height h. So let's assume that this is the height h. So now, here now is a right angle triangle. Here is also a right angle triangle because the height is the perpendicular distance, which is also the longest distance of the triangle. And so it is giving us that down there, right here, is 90 degrees for both sides. So now let's assume that this is angle C, capital C, angle B, and angle A. So I'm going to be having that this side here is side A, this side here is side C, and this side is side B. So now let's assume that these also two right angle triangles combined together. So let's assume that this place from here to down here is my X. And then this place now, since starting from here to here is B, it means that I'm going to be having that this side is B minus X. This can also be interchanged, it doesn't matter. Now we are required to prove the cosine rule, right? So now I'm going to be starting with the first triangle BC. Let me call this place D. So triangle BCD. So now remember, this triangle BCD, if I should extract it from the acute triangle that I have here, I'm going to be having something like this. Don't mind my sketching, please. So I'm having that this is B, this is C, and this is D. And right here is my small a. This is my h, which is the height. And this place is b minus x, which is the base. So if I should use Pythagoras theorem now in this right angle triangle, because this here is now a right angle triangle. So if I should use Pythagoras theorem here, I'm going to be having that a squared, which is the hypotenuse, is equal to h squared plus b minus x squared. Remember, this is what Pythagoras theorem states. So now if I should expand what I have in brackets, I'm going to be having, okay, let me do it separately and then bring it down here. So b minus x, if I should expand it, b minus x squared, I'm going to be having b minus x into b minus x. That's simply what this squared means. It means double of it. So I'm going to be having b times b is b squared, b times minus x is minus bx, minus x times b is minus bx again, minus x times minus x is plus x squared. So I'm going to be having b squared minus 2bx plus x squared. So if I should expand what I have here, this is what I'm going to be getting. So instead of writing this back down, I'm going to be replacing it with this, because after expanding this is what I get. So it means that this here is going to be equal to a squared is equal to, h squared plus b squared minus 2bx plus x squared. So this and this is the same thing. Let me just call this my equation 1. Now for the second triangle, which is triangle BDA. So for triangle BDA, I'm going to also be making use of that Pythagoras theorem there. Let me first of all sketch the triangle that we have there. So let's assume that this is what we have there, triangle BDA. This is my side C, and this is also my height, and this place is my x. So now Pythagoras theorem in this triangle is going to be stating that c squared is equal to h squared plus x squared. And this is what Pythagoras theorem states. Let me call this my equation 2. So now this here is my equation 1 and this here is my equation 2. Now since I'm having that c squared is equal to this in this equation 2, and if you look at this equation 1, you are going to be seeing that so to equate this, firstly I have to make h here the subject, or rather make x, not h, the subject of the formula, because we have x squared here and we also have x squared here. So now I'm going to be having that my x squared is equal to c squared minus h squared. So what I have to do is I have to equate this here. So I have to substitute this into this equation 1. And if I should substitute it, I'm going to be having that a squared is equal to h squared plus b squared minus 2bx plus c squared minus h squared. Now as you can see, I'm having h squared here and h squared here, but this is a negative one and this is a positive one. So these two can simply cancel out each other, and this is what I have remaining. So I can have that my a squared is equal to my b squared plus c squared minus 2bx. Now remember, when we did Pythagoras ratio, when we did trigonometric ratios, I gave us an abbreviation like this. And cos here says the ratio for cos is adjacent over hypotenuse. So now we're going to be making use of this for this cosine rule. So now cosine rules, cos theta here says adjacent over hypotenuse. So now we're going to be coming back to this triangle and we're going to find the adjacent over hypotenuse. So since the side that we have here is side A, I'm going to be finding cos A in this right angle triangle. And to find cos A, we have to assume that the angle that we are given is this A, and cos states adjacent over hypotenuse. And since this is the angle, our adjacent is going to be x. So cos A is equal to x over hypotenuse, which is C. So cos A is equal to x over C. If I should make x here the subject of the formula, I'm going to be having that x is equal to cos A multiplied by C, which is equal to C cos A. Now I'm going to be substituting this into this place that I have my x. So if I should substitute it, I'm going to be having that a squared is equal to b squared plus c squared minus 2bc cos A. And this is simply how we prove that cosine rule works for an acute angle triangle. Remember, if you want to prove this right angle triangle for side B or for side C, you can also do the same thing that I did. The only difference is that instead of working for A, you are going to be working for B or maybe C. Depends on the one that you want. So this here is the proof that cosine rule is actually correct for an acute angled triangle.